So this is a little bit of an alternative version to the concept, but it's called the monkey and the hunter situation. I don't have a monkey or any sort of hunter or bullet-looking objects, so I've substituted for a magnetic protein, don't ask me why I have it, and a TIE fighter as my hunter. So the question is this: if you visualize that monkey is protein, the innocent protein, and the bad guy hunter TIE fighter, the question says, if my protein is sitting on a branch or a tree, as a monkey would do, and my TIE fighter is hunting him, if at exactly the same time the TIE fighter fires a bullet or a missile or a laser, whatever you want to use, at the monkey jumps off the branch. The question is, what's going to happen here? At the exact same time you fire, monkey drops off the branch. Is the monkey just going to free fall straight down and the bullet is going to whiz over the top? Or we know that gravity affects everything, so as soon as it leaves, it's going to start to dip. Will the monkey kind of fall and the bullet will miss over the top of it? Will it just spud into the ground and the monkey will fall much slower? The question is about what's going to happen. Now, when we conduct this experiment, what we find is as long as the time is exact, no matter how far away you are, it always hits. The protein always gets nailed. And the question is, why does this happen? So if we were to break this into components, and I use these magnets to show at time intervals what happens to the motion. So like that multi-image representation. It's falling every second, this is how far it's falling. And we know that because of the acceleration, it would technically be spreading out as it goes, getting further as it speeds up. If I was to plot the bullet or the projectile from whence it fires, it would go say that's something like the path. So what we notice here is two main things. That on every line, the horizontal components are parallel. So this and this are in line with each other. A second later, they're in line with each other. A second later, they're still in line with each other. So even though the spacing may not be the same because it's accelerating, so is this thing. So yes, it's moving horizontally, and the problem is only really an issue if you consider only the horizontal motion, because it's moving in this direction, and we'll say it's moving with a constant velocity. So these arrows are always the same, and it's never changing. We're assuming no air resistance. However, it's also moving downwards with the acceleration due to gravity. And this downward gravity is the same as the monkey's gravity downwards. So as long as they both had initial vertical velocities of 0, so they didn't push off and they weren't fired downwards, they were just fired horizontally and just dropped in free fall, the gravity force acting on them is exactly the same. So they will speed up at exactly the same speed, which means they will both hit the ground at exactly the same time. So as long as the projectile can make the range, it's always going to hit the monkey before or at the same time as it touches the ground.
Bye, have a beautiful time.